Good afternoon, listeners, and welcome to today's class. Today, I would want you to be with me while we look at the problems that concern three concepts in mathematics and statistics called the mean deviation, the standard deviation, and the quartile deviation. So, these questions are raised in such a way that they require the knowledge of these three concepts and the relationship between and among them for one to be able to successfully arrive at the answers. So majorly, we'll be looking at questions concerning mean deviation. Please permit me to manage the size of this board to write M dot D to stand for mean deviation. Then we equally be talking about what we call standard deviation. Permit me to write STD, standard deviation. Okay? And then I will be equally be talking about what we call the quartile deviation. Permit me to write Q dot what D. Of course, you know that this standard deviation is always written as a sigma. As what? Sigma. So we have what we call the mean deviation, what we call the standard deviation sigma, what we call the quartile deviation. So we should be drawing questions, and then in trying to find the solutions of the problems drawn, we will now see how we can deepen our knowledge on these three concepts, especially as it concerns their relationship. So permit me to draw a question from our question bank. This question says, and I read, and let me tag that one, question number one, that we are going to solve. Question number one. If the mean deviation of a set of observation is 8.5, the mean deviation of a set of observations is 8.5. So we now come and write that M dot D of a set of observation equals 8.5. The question further says, then what is the value of the quartile deviation? What is the value of the quartile deviation? That is, our Q dot D equals what? This is the only information you are given, that the mean deviation of a set of data is 8.5, and we are required to find the quartile deviation. So in occasion like this, one needed an idea of this. So let us return to this. It has been proven that the mean deviation of a set of data can be written as this. The mean deviation M dot what D is given as what 4 all over 5 sigma, where this sigma stands for standard deviation, as we earlier had said. This is a relationship of the mean deviation to standard deviation. Equally, it has been stated equally that this quartile deviation, that our what Q dot what D is given as what 2 all over 3 sigma. This is equally a relationship between the quartile deviation and the standard deviation. How do we reconcile these two formulas now in order to be able to solve this problem? What we are going to do is this. So you watch. So I have that 4. So I'll now come here and put solution here. I want to solve the problem. I'll now put solution. So what I have here is that what 4 over 5 sigma equals M dot what D. For convenience, I can write over 1. Okay? Then I can cross multiply. 1 times 4 sigma is 4 sigma. So I have what? 4 sigma equals 5 times md, m dot d is 5, m dot what? D. I can then, making this standard deviation to stand all alone, I divide both sides of the equation with the coefficient of the standard deviation, which here is what is 4. So I have all over what? 4. So I have all over 4 and all over 4. So that this 4 can cancel this 4. And I have that sigma alone is given as what? 5 m dot what? D all over what? 4. I am done making sigma subject of formula from this. I am equally going to do same with this one. So what I'm going to do in this one now, I am equally going to come and write that my 2 all over what? 3 sigma is given as a q dot what? D from this. And for convenience as well, all over what? 1. Then we cross multiply. This 1 will times 2 sigma, and I will have what? 2 sigma is given as 3 times q dot d is 3 q dot what? D. So making sigma solid of formula here now, I will divide both sides with the coefficient of sigma, which in this context is what? Is 2. So I have all over 2, all over what? 2. This and this will cancel. And I have that sigma is given as 3 q dot what? D all over what? 2. I've equally made the sigma subject of what? Of the formula here. So what is left for me to do is to equate the sigmas from the two equations. Now, if this sigma which is here is equal to this sigma, which of course you know it is true, that this sigma and this sigma are the same thing. It implies that this quantity 5m dot d all over 4 is equal to 3 q dot d all over what? All over 2. So I'll come here and say, therefore, that sigma, I'll say, if sigma equals what? Sigma. It implies that 5m dot d all over 4 equals 3 q dot d all over 2. That is, that if this equals to this, it means that this quantity equally equals this quantity, which is what I have. So with this expression, or with this equation, you can easily get at the answer to this question. Because here, look at MD, which was provided. Look at QD, which is required. Everything here are constant, which we know. So I'm now going to say, I'll now come here and say, but my M dot D equals 8.5. Then wherever place I see MD, I will put 8.5 and I will turn here and say, therefore, 5, which is here, multiplied by, in place of M dot D, 8.5, all over what? 4 equals. Here still remains 3 Q dot what? D, all over what? 2. When this multiplied by this, you have a 42.5. So when this multiplied by this, you have a 42.5. Think 42.25 or thereabout. So you now come here and then you'll be able to see that when this thing multiplied by this, you have what we call 42.5 all over what? 4 equals what? 3 q dot what? D all over what? 2. At this point in time, you can cross multiply this time this and this time this. When this time this, you now have that this is what? 12 q dot what? D equals this time this will give you what? 8 what? 5. Then making q dot d as subject of formula here, you are going to have all over what? 12, all over what? 12. So that this can cancel this, and you are left with q dot d. So this, cancelling this will give you something like either 7.08 or thereabout if you press your calculator. And then it implies that if the mean deviation of a set of data is 8.5, the quartile deviation should be 7.08. So I really want to believe that you didn't have a challenge um, as we went about providing solution to this problem. If by any means you did, just feel free to drop your worries or your concern in the comment section. Still remember to like, still remember to comment, and still remember to subscribe to our YouTube channel. How to subscribe legitimately is now to click on the subscription button, then turn on the notification button after watching our videos. You watch our videos, you subscribe, then as you do the subscription, turn on your notification bell or yes, so that each time we upload a new class, you get a notification from the YouTube. Thank you very much. Let us clean this one and draw up another question. So permit me to clean here. Let me now clean this relationship. Okay, in case we might be needing it, let me come and drop that relationship that we drive here, which was that 4 over what 5 m dot what d is given as what 2 over 3 q dot what d. Let us leave this relationship which we had here so that we will not be looking for it. So permit me to clean it. If we need it, we drive it once again. This question we are going to solve now says, and I read. Question says, and read. The question says, if the first quartile is 104, if the first quartile is 104, first quartile is 104. So I am going to represent, this is question number 2. I am going to represent that first quartile with Q subscript 1. So I have what? Q subscript 1 is given as a 1014. And the quartile deviation is 8. And the quartile deviation is what? Is 8. So that quartile deviation is here. They say, and quartile deviation, my Q dot what? D equals what? 8. They say, find the third quartile. They are asking me, I should go and look for Q subscript 3 is what? That is to say, that one is giving the first quartile from a set of data to be 104. One is told that the quartile deviation is 8, and then one is told to find the value of is asked to find the value of the third quartile, Q subscript what 3. So what we are going to do first of all is to look out for a relationship between the Q1, QD, and then the Q3. Of course, you know that another name of quartile deviation is semi-interquartile range. And this quartile deviation is given as the quartile deviation that my Q dot D is given as what? That Q what 3 minus what? Q1 all over what? 2. This is the formula for the quartile deviation. The formula we gave here is a formula that showcases the relationship between the quartile deviation and the standard deviation. But if you watch here now, everything here is about quartile. This is quartile, this is quartile. Talking about the third and talking about the first. But in this case, we are talking about quartile without specifically talking about whether it is the first or the second or the whatever. Then, and we are talking about the standard deviation. So what we are going to do here is, of course, having recorded this formula now, we return back. So anytime they ask you to find the quartile deviation, this is the formula. The third quartile minus the second quartile all over 2. So where we have been provided the first quartile to be 104, we have been provided the quartile deviation to go to be 8. So in place of this quartile division here, I can equally write over 1 here for convenience, as I will always say. So what I have here is quartile division is 8. I'll have 8 all. Then here is what 1 equals. I am asked to find Q3, so I'll write what Q3 minus. I've been told that this is 104, so I have 1 over 4 all over what 2. When one multiply by a word of multiplication, when one multiplies everything here, it remains everything there. And what I have there becomes what Q3 minus 1 over 4 equals. Then this will multiply this, and then 2 times 8 will give me what? 16. Of course, this 104 and 16 are like terms because they are numbers and should be collected together, leaving the variable or the unknown at the left-hand side of the equation. This is what we regard for unknown here, the Q3. So this 104 should be going over there. And this 104 going over there, bearing negative here now on going over there, it becomes a positive sign. So what I have becomes what Q3 now is given as what? 16 plus 1 over 4. And then therefore, my Q subscript 3 now is become what? 120. See? Becomes what? 120. So that's exactly how to go about this. That's how to go about this. So in a problem like this, you can be given the Q3, you can be given the quartile division, you can be given the Q1, and you are asked to find the remaining parameter. So the only thing you are going to do for me is to equally remember this relationship. Remember this relationship. Just like I plead with you to remember this relationship. I've always said that you can get yourself a jotter, you can get yourself a jotter, and be writing down these formulas, which we always emphasize are actually helpers when we are looking for solutions of some problems. The moment you can record them, you can go a long way to providing answers to that question. I still want to believe that you didn't have a problem. If you do, drop your question in the comment section. Let us go over to the next question. So permit me to clean here. Permit me to clean here. Okay, look at another question. They say if the third quartile, so I'll write this one number 3. If the third quartile is 20, if the third quartile of a set of data is 20, you are going to permit me to write that third quartile as Q subscript 3. So they say that Q subscript 3 is given as what? 20. And the first quartile is 10. So you permit me to write that Q subscript 1 is given as what? 10. And they ask me, what is the value of the coefficient of quartile deviation? The value of the coefficient of quartile deviation. You are going to permit me to write that in C dot Q dot D. That is coefficient of quartile deviation. They say is equals to what? You see, in a problem like this, what we are going to do now is to look out for the relationship between the Q3, the Q1, and then the coefficient of quartile deviation. And it has been defined that the coefficient of quartile deviation is given as that by way of solving it, I'll have solution. It has been given that my C dot what? Q dot D is given as Q3 minus Q1 all over Q3 plus Q1 all multiplied by 100. That's what we are doing. Permit me to put the source of my light on. So we are given this formula. So what do we do? What we do is we know our Q3, we know our Q1. We come and put it in here and evaluate the quantity, and it becomes what the answer. So what I'm going to say is therefore my C dot q dot g is given as this is 20. So I have 20 minus this is what 10 all over. Here this is what 20 plus. Here this is what 10. This way multiply by 100. Of course, 20 minus 10 is what is 10, and then this will be able to give me 10 all over. Here is 20 plus 10 will give me what? 30 all multiplied by 100. I can say all over 1. So in this case, of course, I have 10 times this will give me what? 10 times 100 will give me 1000. So, or if I don't want to go into that way, this knot will cancel this knot. So I am left with what? 100 all over what? 3. Which will give you around 30 point something. So the moment you evaluate this, 100 over what? 3. That is what we call the coefficient of a quartile deviation. Coefficient of quartile deviation. So the moment they ask you this kind of problem, please do me a great favor by remembering this formula for me. We always have what we call coefficient of variation, coefficient of regression, coefficient of this. This is coefficient of quartile deviation. Coefficient of quartile deviation. Thank you very much. Permit me to clear here while we draw another question. So I'll clear. Okay. Let's look at this question together. Okay. That question says, and I read. Okay. Okay, it's more or less of now they say, if for a moderately symmetrical distribution, if for a moderately symmetrical distribution, the mean deviation is 12. The mean deviation is 12. That is question number 4. I'll say m dot d equals what? 12. That's what they told us. Then the value of the standard deviation is what? The value of the standard deviation is what? So they are asking me that my sigma now is equals what? If this one is given at this should be what? Of course, what is going to help us come out of this problem victoriously is to recall the relationship we gave about the m dot d to the standard deviation. So I'll just call up this problem now and we use it to solve this thing. And of course, it becomes that m, as a way of solving it, I'll write solution. And then what I have is that what? My m dot d equals, I have what? 4 over 5 sigma. I will now say, but my m dot d equals what? 12. Then in place of m dot d, I will say 12. For convenience, all over 1 is given as 4 sigma all over what? 5. So I will cross multiply. 1 will times this. I will now have that 4 sigma is given as this times this. So I have what? 12 times what? 5. So making this to stand alone, I have all over 4, all over 4. So at this 4 will cancel this 4, and I'll have sigma alone is given as this. As a way of reducing this, 4 into if self is 1, 4 into 12 is what? 3. So that I will be able to have 3 times what? 5, to have what? 15. So if the mean deviation of a set of data is 12, the standard deviation of that data should be what? Should be 15. You see a strong relationship that exists between these. You understand? Okay? Now, as a way of extension of this class to something that is going to be beneficial to our listeners or audience, you see, these quartiles that we are talking about, our Q1, our Q2, and the rest of them, are often used to prepare what we call the box plot. And this box plot we talk about is one of the graphical approach of looking at the distribution of a data set, where we now talk about the Q1, the Q2, and then the Q3 forming the box, then while the minimum and the maximum value forming what we call the winkers in the box plots. So we are going to showcase this thing now using maybe a sketch and the rest of them. And then you can easily use this box plot now to look out for an observation that should be regarded as what? As an outlier. That is an extreme observation that is a value is far away from the mean of the rest of the observations. Okay, so permit me to clean this thing. Assuming one is given a set of observation, be it an array or be it from a group frequency, sorry, from an ungrouped frequency table, and one is told using that data set now prepare a box plot and be able to see one or two things about the nature of the distribution of that what data or the distribution of the process where the data is coming from. Of course, what you are going to do first of all is from that set of data, note what is your maximum value and note what is your minimum value. So from that data, you are going to look for what is called minimum value. Equally look for what is called maximum value from that data. Maximum value. When you are done looking for minimum and maximum value, you go ahead and compute what is called your first quartile, the second quartile, which of course is the median, and then the third quartile, which I am going to represent with. I have my Q1 talking about the first quartile. Then I have my Q2 talking about what? My second quartile, which is what? The median, and then talking about my Q3, which is the third quartile. Okay? Then with this, you'll be able to have a box this way. You'll be able to have a box this way. You're able to have a box this way. Have a box this way. Of course, there is this line have to contain numbers so that once you compute the value of your minimum, you'll be able to know where your minimum lies. If your minimum says 20, from that a line that is here that contains the numbers now, you'll be able to know where 20 is. If the maximum is something like 90, you'll be able to know where the maximum is. So for instance, in this case now, if I have that minimum is 20, you see me having something like this, still having something like this, then I have something like this, talking about what? 20, which is my minimum. So, and then you see me have something like this, perhaps it's 90, talking about what? The maximum. Then here, of course, this particular line here is the line of what? Of Q1. So you have what you call your Q1 here. The line at the center of this box like this, at the center of this box like this, ordinarily should be what? The median, which is the Q2. I use the word ordinarily because you might compute it now and the value doesn't fall in the what? In the center. And of course, that will help you now to begin to know whether that distribution is skewed or whether it is not what skewed. But if it falls in the center, of course, we know that it is either that the thing is what? Fairly distributed or normally distributed, or maybe it is what we call is it's not skewed much. You understand? So we have this one to become what? Q2. have it to be what? Q2, Q2. Then, of course, this value that is here, this value that is here, this value that is here is what we call our Q3. And of course, this is what we call the box plot. The box plot. Box plot. We can use it now to see the distribution of data and the rest of them. Okay? So, and then they gave something. What they gave something that they, for us to be able to use that thing to find what is what an outlier. What is what an outlier. Because you might, after preparing this thing now, we now see how do we now use this thing we are prepared now to see if a particular observation is an outlier. They gave a range, and that range they gave is this. They say that Q3 plus 1.5 of interquartile range. Interquartile what? Range. Or what we call the quartile range. Interquartile range. I'll write it as I interquartile range. Let me write as what? IQR. Then they also give Q1 minus 1.5 of IQR, which is interquartile range. They say when you must have computed your interquartile range, and of course the interquartile range, like I earlier had said, is just like your quartile range. So if you compute your interquartile range, then equally you now compute your what? Your third quartile. Then you now say 1.5 times your interquartile range. Then you add it to this your Q3. This one, you use 1.5 now to multiply this interquartile range now. Subtract it now from what? From your Q1. Any observation that falls outside this range is regarded as what? As an outlier. That is what they are trying to say here. So you can equally use the idea of this now to locate what you call your outlier. Sure. So this is a little that we want you to learn from us in our today's class. Hoping and believing that in our next class, we're equally going to bring to you what will continue to add value to you on your knowledge of what mathematics and statistics. Thank you very much, and God bless you.